हेलो बच्चों, इस एपीसोड विच तुसी इन्हां बारे सीखोगे बेसिक कॉन्सेप्ट्स ऑफ वेक्टर्स, रिप्रेजेंटेशन ऑफ वेक्टर्स, टाइप्स ऑफ वेक्टर्स, addition of vectors and their laws, subtraction of vectors and their laws। आओ हुण शुरू करिए। Before discussing the vectors, first we will discuss scalar and vector quantities. Scalar, a quantity having only magnitude, is called scalar quantity. For example, mass, volume, density, work, temperature, distance, area, real numbers, etc. are the scalar quantities. Vector, a quantity having both magnitude and direction, is called vector quantities. For example, displacement, velocity, acceleration, momentum, force, moment of a force, weight, etc. are vector quantities. A directed line segment AB is called vector AB. The vector AB starts from point A, which is called its initial point, and ends at the point B, which is called its terminal point. Magnitude of a vector, the distance between initial and terminal points of a vector, is called the magnitude or length. It is denoted by mode of vector AB. Direction cosines, the angles alpha, beta and gamma made by the vector R with the positive directions of x, y and z axis respectively, are called its direction angles. The cosine values of these angles, that is cos alpha, cos beta, cos gamma, are called direction cosines of the vector R and usually denoted by L, M and N. Suppose a car travels a certain distance in one direction and travels back the same distance. Clearly, the vector showing the movement of the car will have the same magnitude as they have travelled the same distance, but they will be opposite in direction. Such vectors having the same magnitude but opposite directions are called opposite vectors. Every non-zero vector has exactly one opposite vector to itself, which is denoted by the negative of that vector. You can also say that a vector with the same magnitude but opposite in direction to a given vector is called the negative of that vector. The opposite vector to the negative vector is the vector itself. Consider two cars traveling the same distance in the same direction. The displacement of each car can be represented by a vector. As the distance travelled by two cars is same, the vectors have same magnitude. Also, the vectors have same direction as the direction of two cars is same. Since the magnitude as well as direction of the two cars is same, their movement can be represented by the same vector. Such vectors having same magnitude as well as direction are called equal vectors. The specific position of a vector is of no importance. On the contrary, the vectors which are not equal are called unequal vectors. The movement of two cars traveling the same distance but in opposite direction represent unequal vectors. Similarly, the movement of two cars covering different distances but in same direction also represents unequal vectors. Suppose two cars start moving from the same point but in any direction. As the starting point of both the cars is same, the vector representing the movement of the cars will have same initial point. Such vectors having same initial point are called co-initial vectors. This helps us to generalize that two or more vectors having the same initial point are called co-initial vectors. Let us learn to replace a given system of vectors by a system of co-initial vectors. Consider vector A and vector B and suppose O be the given initial point. To make these vectors co-initial vectors, draw vector OE parallel and equal to vector AB. Similarly, draw vector OF parallel and equal to vector CD. Then the system of vectors AB and CD is same as system of vectors OE and OF. This helps us to generalize that any given system of vectors can be replaced by a system of co-initial vectors having a given point as the initial point. Consider two cars moving parallel to the divider of the road in the same direction. The movement of these two cars can be represented by two vectors parallel to each other having the same direction. Now consider two cars moving parallel to the divider of the road in the opposite direction. The movement of these two cars can be represented by two vectors parallel to each other having opposite directions. Such vectors which are parallel to the same line are called the collinear vector. If two vectors A and B are collinear, either of them can be expressed in terms of other, such as vector A is equal to lambda times vector B, where lambda is any scalar. Conversely, if one vector A can be expressed in terms of another vector B, then vector A and vector B must be collinear. Now we will learn addition of vectors. We can find the addition of vectors by two methods: triangle law of vector addition and parallelogram law of vector addition. First, we discuss the triangle law of vector addition. If a boy moves from A to B and then from B to C, the net displacement made by the boy from point A to point C is expressed as vector AB plus vector BC is equal to vector AC, or vector A plus vector B is equal to vector C. This is known as the triangle law of vector addition. Now discuss the parallelogram law of vector addition. If we have two vectors OA and OB, that is A and B represented by the two adjacent sides of a parallelogram in magnitude and direction, then their sum is vector A plus vector B, which is represented in magnitude and direction by the diagonals of the parallelogram through their common point. Draw the parallel vectors BC to OA and AC to OB. The total displacement from O to C can be found by two types: from A to C by A and by B. In both the cases, the sum of the vectors is vector A plus vector B. This is known as the parallelogram law of vector addition. Here we will discuss the properties of vector addition. First, the addition of two vectors is commutative. For two vectors A and B, the addition of vectors A and B is commutative. That is, vector A plus vector B is equal to vector B plus vector A. Now it's proved. If vector A and vector B are two vectors, then we shall show that vector A plus vector B is equal to vector B plus vector A. This property can be proved by parallelogram law of vector addition. Let vector A and vector B represented by vector OP and vector PQ respectively. Complete the parallelogram OPQR. Then vector OP is equal to vector RQ equal to vector A, and vector PQ is equal to vector OR equal to vector B. The displacement from O to Q via P is equal to vector OP plus vector PQ, which is equal to vector A plus vector B. Also, the displacement from O to Q via R is equal to vector OR plus vector RQ, which is equal to vector B plus vector A. From both the equations, vector A plus vector B is equal to vector B plus vector A. So we can say that the addition of vectors is commutative. Here we discuss the second property of addition of vectors. For three vectors, vector A, vector B and vector C, the addition of vectors is associative, that is vector A plus sum of vectors B and C is equal to sum of vectors A and B plus vector C. Now it's proof. If vector A, vector B and vector C are three vectors, then we shall show that vector A plus sum of vector B and C is equal to sum of vectors A and B plus vector C. Let vector A, vector B and vector C represented by vectors PQ, vector QR and vector RS respectively. We have to find the net displacement from P to S. So we draw a diagonal PR by using triangle law of vector addition. Vector PR is equal to vector PQ plus vector QR. That is, it is equal to vector A plus vector B. Now vector PS is equal to vector PR plus vector RS. That is sum of vectors vector A and vector B plus vector C. Now for the second case, draw the diagonal QS, and by using triangle law of vector addition, vector QS is equal to vector B plus vector C. Now the net displacement from P to S, PS is equal to vector PQ plus vector QS, that is vector A plus sum of vector B and C. From both the equations we get the required result, and we can say that sum of three vectors A, B and C is associative. If A and B are two vectors as shown, then the subtraction of vector B from vector A is defined as the vector sum of vector A and minus vector B, which is denoted by vector A minus vector B.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਵੈਕਟਰਸ, ਵੈਕਟਰ ਦੀ ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨ, ਟਾਈਪਸ ਆਫ ਵੈਕਟਰਸ, addition of vectors, subtraction of vectors and their laws ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example. If vector A, vector B and vector C be the vectors represented by sides of a triangle taken in order, then prove that vector A plus vector B plus vector C is equal to 0. Vector ਪਰ ਜੇਕਰ vector A, vector B ਅਤੇ vector C ਇੱਕ triangle ਦੀ ਸਾਈਡਸ ਦੁਆਰਾ represent ਕੀਤੇ ਜਾਂਦੇ ਹਨ, ਜਿਨ੍ਹਾਂ ਨੂੰ ਇੱਕ ਆਰਡਰ ਵਿੱਚ ਲਿਆ ਗਿਆ ਹੈ, ਤਾਂ ਪ੍ਰੂਫ ਕਰੋ ਕਿ vector A ਜਮਾ vector B ਜਮਾ vector C ਬਰਾਬਰ ਹੈ 0 vector. Now its solution. Let triangle ABC be a triangle such that vector BC is equal to vector A, vector CA is equal to vector B, and vector AB is equal to vector C. Now vector A plus vector B plus vector C is equal to vector BC plus vector CA plus vector AB, that is equal to vector BA plus vector AB, because we know that in a triangle ABC, vector BC plus vector CA is equal to vector BA which is further equal to vector BB by triangle law and that is equal to 0 vector that we get by definition of null vector. So here vector A plus vector B plus vector C is equal to 0 vector. Hence we can say that vector A plus vector B plus vector C is equal to 0 vector if they are represented by sides of a triangle। ਭਾਵ ਜੇਕਰ ਵੈਕਟਰ A, ਵੈਕਟਰ B ਅਤੇ ਵੈਕਟਰ C ਕਿਸੇ ਟ੍ਰਾਇੰਗਲ ਦੀ ਸਾਈਡਸ ਦੁਆਰਾ ਰਿਪਰੈਜ਼ੈਂਟ ਕੀਤੇ ਜਾਂਦੇ ਹਨ ਜਦੋਂ ਕਿ ਇਹਨਾਂ ਨੂੰ ਇੱਕ ਆਰਡਰ ਵਿੱਚ ਲਿਖਿਆ ਜਾਵੇ ਤਾਂ ਅਸੀਂ ਕਹਿ ਸਕਦੇ ਹਾਂ ਵੈਕਟਰ A ਜਮਾ ਵੈਕਟਰ B ਜਮਾ ਵੈਕਟਰ C ਬਰਾਬਰ ਹੈ 0 ਵੈਕਟਰ, ਜੋ ਕਿ ਅਸੀਂ ਪ੍ਰੂਵ ਕਰਨਾ ਸੀ। Now let's see another example. Find the sum of vectors vector P equal to 9 I cap minus 7 j cap plus 8 k cap, vector Q equal to 5 I cap plus 3 j cap minus 7 k cap, and vector R equal to 3 I cap minus 4 j cap minus 5 k cap। ਭਾਵ ਇਹਨਾਂ ਵੈਕਟਰਸ ਦਾ ਸਮ ਪਤਾ ਕਰੋ। ਦਿੱਤੇ ਗਏ ਵੈਕਟਰਸ ਹਨ वेक्टर P बराबर 9 I कैप माइनस 7 J कैप जमा 8 K कैप, वेक्टर Q बराबर 5 I कैप जमा 3 J कैप माइनस 7 K कैप अते वेक्टर R बराबर 3 I कैप माइनस 4 J कैप माइनस 5 K कैप। Now its solution. Here given vectors are vector P equal to 9 I cap minus 7 J cap plus 8 K cap, vector Q equal to 5 I cap plus 3 J cap minus 7 K cap, and vector R equal to 3 I cap minus 4 J cap minus 5 K cap। Then vector P plus vector Q plus vector R is equal to 9 I cap minus 7 J cap plus 8 K cap plus 5 I cap plus 3 J cap minus 7 K cap plus 3 I cap minus 4 J cap minus 5 K cap, that is further equal to 9 I cap plus 5 I cap plus 3 I cap plus minus 7 J cap plus 3 j cap minus 4 j cap plus 8 k cap minus 7 k cap minus 5 k cap, that is further equal to 9 plus 5 plus 3 into I cap plus minus 7 plus 3 minus 4 into j cap plus 8 minus 7 minus 5 k cap, and that is equal to 17 I cap plus minus 11 plus 3 j cap plus 8 minus 12 k cap, and that is equal to 17 I cap minus 8 j cap minus 4 k cap. Therefore, for the given vectors p, vector q and vector r, their sum, that is vector p plus vector q plus vector r, is equal to 17 I cap minus 8 j cap minus 4 k cap. इस तरह दिए गए एग्जाम्पल ਲਈ वेक्टर p, वेक्टर q ਅਤੇ वेक्टर r ਦਾ ਸਮ ਬਰਾਬਰ ਹੈ 17 I cap minus 8 j cap minus 4 k cap, ਜੋ ਕਿ ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ. Now let's see another example. Find the values of x, y and z if the sum of vectors, vector a equal to 3 I cap minus y j cap plus k cap and vector b equal to x I cap plus 5 j cap minus z k cap is equal to the sum of vectors, vector p equal to 3x I cap plus 5 j cap plus 4 k cap and vector q equal to 4 I cap plus 2 y j cap plus 3 z k cap. ਭਾਵ x, y ਅਤੇ z ਦੀ ਵੈਲਿਊਜ਼ ਪਤਾ ਕਰੋ ਜੇਕਰ वेक्टर a ਅਤੇ वेक्टर b ਦਾ ਸਮ ਬਰਾਬਰ ਹੋਵੇ वेक्टर p ਅਤੇ वेक्टर q ਦੇ. Now its solution. Here it is given that sum of vector a and vector b is equal to the sum of vector p and vector q. Also, vector a is equal to 3 I cap minus y j cap plus k cap. Vector b is equal to x I cap plus 5 j cap minus z k cap. Vector p is equal to 3x I cap plus 5 j cap plus 4 k cap and vector q is equal to 4 I cap plus 2y j cap plus 3z k cap. Now as per given, the sum of vector a and vector b is equal to sum of vector p and q. This implies 3 I cap minus y j cap plus k cap plus x I cap plus 5 j cap minus z k cap is equal to 3x I cap plus 5 j cap plus 4 k cap plus 4 I cap plus 2y j cap plus 3z k cap further implies that 3 I cap plus x I cap plus minus y j cap plus 5 j cap plus k cap minus z k cap is equal to 3x I cap plus 4 I cap plus 5 j cap plus 2y j cap plus 4 k cap plus 3z k cap implies that 3 plus x into I cap plus minus y plus 5 into j cap plus 1 minus z into k cap is equal to 3x plus 4 into I cap plus 5 plus 2y into j cap plus 4 plus 3z into k cap. Now on comparing, we get 3 plus x is equal to 3x plus 4 minus y plus 5 is equal to 5 plus 2y and 1 minus z is equal to 4 plus 3z. So we get 3 linear equations on solving. We get x minus 3x is equal to 4 minus 3 implies that minus 2x is equal to 1 further implies x is equal to minus 1 upon 2. Now solving the next equation, we get minus y minus 2y is equal to 5 minus 5 implies that minus 3y is equal to 0 further implies y is equal to 0. Now on solving the next equation, minus z minus 3z is equal to 4 minus 1 implies that minus 4z is equal to 3 implies that z is equal to minus 3 upon 4. So here we get the values of x, that is equal to minus 1 upon 2, y equal to 0 and z equal to minus 3 upon 4. So therefore, for the given example, x is equal to minus 1 upon 2, y is equal to 0 and z is equal to minus 3 upon 4. ਭਾਵ ਇਸ ਤਰ੍ਹਾਂ ਦਿੱਤੇ ਗਏ ਐਗਜ਼ਾਮਪਲ ਲਈ x ਦਾ ਮੁੱਲ ਹੈ -1/2, y ਬਰਾਬਰ ਹੈ 0 ਅਤੇ z ਬਰਾਬਰ ਹੈ -3/4 ਦੇ, ਜੋ ਕਿ ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ।
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਵੈਕਟਰਸ, types of vectors, representation of vectors, addition and subtraction of vectors and their laws ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example. Find the values of a, b and c if the sum of vectors vector p equal to 3 I cap minus b j cap plus 2 k cap and vector q equal to 5 I cap plus 6 j cap minus 6 k cap is equal to vector r equal to 3 a I cap plus 7j cap minus 5k cap। ਭਾਵ A, B ਅਤੇ C ਦੀ ਵੈਲਿਊਜ਼ ਪਤਾ ਕਰੋ ਜੇਕਰ ਵੈਕਟਰ P ਅਤੇ ਵੈਕਟਰ Q ਦਾ ਸਮ ਵੈਕਟਰ R ਦੇ ਬਰਾਬਰ ਹੋਵੇ। Now its solution. Here we have vector P equal to 3i cap minus bj cap plus 2k cap. Vector Q equal to 5i cap plus 6j cap minus ck cap, and vector R equal to 3ai cap plus 7j cap minus 5k cap. Also, it is given that vector P plus vector Q is equal to vector R. Now, placing the values of vector P, vector Q and vector R, we get 3i cap minus bj cap plus 2k cap plus 5i cap plus 6j cap minus ck cap is equal to 3ai cap plus 7j cap minus 5k cap, implies that 3i cap plus 5i cap plus minus bj cap plus 6j cap plus 2k cap minus ck cap is equal to 3ai cap plus 7j cap minus 5k cap. Further implies 3 plus 5 into I cap plus minus b plus 6 into j cap plus 2 minus c into k cap is equal to 3a I cap plus 7 j cap minus 5 k cap, implies that 8 I cap plus minus b plus 6 into j cap plus 2 minus c into k cap is equal to 3a I cap plus 7 j cap minus 5 k cap. Now on comparing, we get 8 is equal to 3a minus b plus 6 is equal to 7 and 2 minus c is equal to minus 5. So this implies a is equal to 8 upon 3 minus b is equal to 7 minus 6, that is equal to 1, and minus c is equal to minus 5 minus 2, that is equal to minus 7. So this implies a is equal to 8 upon 3, b is equal to minus 1, and c is equal to 7. So these are the values of a, b and c. So पार्ट इस तरह दिते गए एग्जांपल ਲਈ a बराबर है 8/3, b बराबर है -1 ਅਤੇ c बराबर है 7, जो कि ਅਸੀਂ पता करना है. Now let's see another example. Find the difference of the vectors vector m equal to 5 I cap plus 3 j cap plus 4 k cap and vector n equal to 7 I cap plus 3 j cap minus 6 k cap पाव वेक्टर्स वेक्टर m बराबर 5 I cap जमा 3 j cap जमा 4 k cap ਅਤੇ वेक्टर n बराबर 7 I cap जमा 3 j cap minus 6 k cap विचकार डिफरेंस पता करो. Now its solution. Here the given vectors are vector m equal to 5 I cap plus 3 j cap plus 4 k cap and vector n equal to 7 I cap plus 3 j cap minus 6 k cap. Let vector p is equal to difference of vector m and vector n. Therefore, we can say that vector p is equal to vector m plus additive inverse of vector n. So for vector n, that is equal to 7 I cap plus 3 j cap plus 6 k cap, its negative or additive inverse, that is negative vector n, is equal to minus of 7 I cap plus 3 j cap minus 6 k cap, implies that negative vector n is equal to minus 7 I cap minus 3 j cap plus 6 k cap. Then the vector p, which is equal to vector m plus additive inverse of vector n. So this is equal to 5 I cap plus 3 j cap plus 4 k cap plus minus 7 I cap minus 3 j cap plus 6 k cap, further equal to 5 I cap minus 7 I cap plus 3 j cap minus 3 j cap plus 4 k cap plus 6 k cap. So it is equal to 5 minus 7 into I cap plus 3 minus 3 into j cap plus 4 plus 6 into k cap, which is equal to minus 2 I cap plus 0 j cap plus 10 k cap, that is equal to minus 2 I cap plus 10 k cap. So therefore, vector p is equal to minus 2 I cap plus 10 k cap. Thus, for the given example, difference of vector m and vector n is equal to minus 2 I cap plus 10 k cap. अब इस तरह दिते गए वेक्टर्स वेक्टर m ਅਤੇ वेक्टर n ਦਾ डिफरेंस बराबर है माइनस 2 I cap जमा 10 k cap ਤੇ, जो कि ਅਸੀਂ पता करना ਸੀ. इस एपिसोड ਵਿੱਚ ਤੁਸੀਂ ਸਿੱਖਿਆ ਹੈ बेसिक कॉन्सेप्ट ऑफ वेक्टर, रिप्रेजेंटेशन ऑफ वेक्टर, टाइप्स ऑफ वेक्टर्स, addition of vectors and their properties, subtraction of vectors and their properties.
इस एपिसोड ਵਿੱਚ ਤੁਸੀਂ बेसिक कॉन्सेप्ट्स ऑफ वेक्टर्स, रिप्रेजेंटेशन ऑफ वेक्टर्स, टाइप्स ऑफ वेक्टर्स, addition of vectors and their law and subtraction of vectors and their laws ਬਾਰੇ ਜਾਣਿਆ ਹੈ. ਉਮੀਦ ਕਰਦਾ ਹਾਂ ਤੁਹਾਨੂੰ ਐਪੀਸੋਡ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ. ਧੰਨਵਾਦ।